In this video, you'll see tests that prove static flow rates to be meaningless and to be potentially counterproductive. Let's start with some common knowledge. Inadequate water consumption limits bird weight gain. So maximizing water consumption, the water actually ingested by the bird, is an important goal. Unfortunately, people are confused about how to achieve this goal. Some people promote using flow rate standards, thinking they help maximize water consumption. To paraphrase the conclusion, quote, nipple flow rates should be measured to ensure optimal broiler performance, and goes on to say, measuring nipple flow rate allows growers and service personnel to easily ensure adequate drinking water flow rate. Some standards even require a specific drinker flow rate based on bird age, as measured by a static flow rate test. This article specifies 7 milliliters per minute per week of age, plus an additional 20 milliliters per minute. Wanting to establish a standard is understandable, but what if those standards are actually counterproductive to bird performance when used in the real world? Much rides on these standards, so it's critical to subject them to rigorous scrutiny. Today's standards are established using a field-conducted flow rate test. In this test, the drinker's trigger pin is pushed up and held for 1 minute. Let's review how this test is conducted. The drinker trigger pin is pushed up and held up in an open position for 1 minute. Then the water volume discharge is measured. The producer sets column pressure at the level needed to achieve the required drinker discharge or flow rate, which we will call static flow rate because the trigger is pushed up and held in a static open position for 1 minute. Now, let's compare this test method to a bird actually drinking. When birds drink, the action is dynamic. Peck, release, and each peck is different. It is not static. You never see a bird lift and hold the trigger pin in an open position like this. The difference between the bird's actual dynamic drinking behavior and the static flow rate test is easy to see. This being the case, it is important to find out if there is a direct and predictable correlation between static flow rate and dynamic flow rates. Our Poultry Watering U technical team set out to find an answer using controlled testing methods. First, the team developed a machine that produces a triggering action that's similar to the way a bird actually drinks. We will test drinkers for their dynamic and static flow rates. Let's review the tests. Here are two different drinker models being tested using the static flow rate method with the same column pressure for the same amount of time. After 1 minute, drinker B discharged approximately 109% more water than drinker A in the static flow rate test. Now we will test the same two drinkers using the dynamic side-to-side activation test that resembles the way a bird activates the drinker. Logically, for the static test to be valid, drinker B must also discharge more water than drinker A using this dynamic flow test. Let's see. In the dynamic flow test, drinker A actually discharged about 120% more water than drinker B. This is completely opposite to the static flow rate test result. To reiterate, drinker B discharged 109% more water than drinker A in the static flow rate test, but drinker A discharge 120% more water in the dynamic flow rate test. Clearly, you cannot depend on a static flow rate test to gauge or accurately predict how much water a drinker will really discharge when activated dynamically by the birds. So a high static flow rate does not guarantee a high dynamic flow rate. The simple truth is that static flow rate standards are meaningless and, therefore, should not be used as a criteria for selecting one drinker model over another for use in a poultry facility. But most importantly, static flow rates should not be used to determine watering system pressure settings. Using these standards will more likely result in delivering too much or too little water for optimum bird performance. In fact, there's probably no accurate way to measure actual bird water consumption, that is, water ingested by the bird. But there is a better way to manage poultry watering systems to promote dry litter, bird welfare, and performance. It's a simple matter of observing litter conditions and managing the system based on these conditions. This document can help you do that. Visit our website for more video and a practical management procedure to maximize performance.